Welcome everyone, we're standing here today at the Hydrogen Technology Expo in Bremen, organized by Trans Global Events. My name is Johan Wieber from the Hydrogen Standard, and with me here today is Koen Driessen from Spark Nano. Welcome Koen.
Hi, good afternoon.
Good afternoon, thank you for joining us in this session. So Spark Nano, tell us all about it. What does the business do?
Yeah, so Spark Nano, we are a spin-out from Thier, which is a Dutch research organization. And we're commercializing spatial atomic layer deposition, which is a chemical process that can apply very thin coatings, which can be used in many applications. But of course here we are focusing on the hydrogen and fuel cell applications.
Focusing on the hydrogen and fuel cell applications, why is hydrogen, for example, important for your business?
Well, hydrogen is one thing, but making green hydrogen is of course what we're all after. And therefore PEM electrolyzers and PEM fuel cells are very critical, and helping them develop this in a very efficient way, that's what we can do.
And what sort of way is sort of the Spark Nano way in terms of like developing PEM fuel cells?
Yeah, so in the PEM fuel cells you have of course very scarce and expensive materials like iridium and platinum. And that's a very scarce and material which you really want to apply in a very, very efficient way. So doing that with spatial atomic layer deposition, we really can control and use every atom available of iridium and platinum to make very efficient, not just cost efficient, but also in performance, electrolyzers and fuel cells.
Yeah, so raw materials and particularly precious metals are obviously considered one of the stumbling blocks in rolling out PEM technology. And what you're offering, if I understand it correctly, is machines that can reduce the amount of raw materials required to coat, for example, the applications in a PEM electrolyzer.
Yes, exactly. So every atom of iridium we should use efficiently, because if you want to do all the electrolysis with PEM electrolyzers, there is simply not enough iridium on this planet to do that. And also the usage, and therefore not spilling or overcoating membranes or PTLs, is something that we can facilitate in a very, very efficient way. And therefore, yeah, this technology allows you not just to save material, but also use it to the maximum. So in the process of applying it with spatial atomic layer deposition, you really can account for every atom to be used in a very, very efficient way. So we don't coat thicker than needed. We can coat on porous substrates like PTL, and really control also the depth that we do. So it's not just about thickness, it's also about really using enough catalyst material to be efficient.
So as far as my understanding goes, and it's quite limited obviously compared to yours in this field, there's ALD and spatial ALD, and you guys focus and specialize in spatial ALD. Can you tell us a little bit what the difference is and why does it matter?
Yeah, so ALD is already quite an old technology. Let's say it's 30, 40 years old, and very often used in semiconductor applications. There are big companies doing that. But it is a batch process, so you need a vacuum, and the substrates are loaded into a vacuum chamber. It's pumped down, there is flushing, there is and so on. And everything inside that vacuum chamber is coated. Also the rejector walls are coated and so on. Now, spatial ALD is a newly developed technology, which originally is developed also for flexible electronics, but also flexible solar panels and also the flexible displays that you see all around. Mm. But this spatial ALD is not a batch process. It is at atmospheric pressure, and therefore it can be very sizable. So we can scale up to big sizes, which is needed if you want to make big solar panels or big displays or big electrolyzers. So that's important. Secondly is speed, because we don't have to pump down, we don't have to purge. It's a motion instead of a batch process. Therefore you can be much faster, which is needed if you need high volume production like PEM electrolyzers or PEM fuel cells. Yeah? So there are some key advantages that this new developed spatial ALD gives to new applications like hydrogen generation and fuel cells.
Talking about sort of the various applications, and the hydrogen space is obviously not the only one in which you guys are sort of active in using your technology. What sort of other markets relates to energy or some other industries are you active?
Yeah, so our machines cost money, and so we have to add value. Doing this on solar is already widely accepted, but yeah, then you really have to have a special type of solar panel to be able to use our equipment. If you have very newly developed stack designs and so on, then we can do something. But we do focus on green applications, so hydrogen and fuel cells, or electrolyzers and fuel cells obviously, but also batteries, which of course is a huge thing at this moment also in the green quest, in storing green energy and so on. So there we coat anodes and electrodes. We do also, which is a bit off topic, let's say, optical devices, AR and VR applications, but that's more a niche. But we try to keep and focus on the green applications, which are the trees, including batteries next to hydrogen.
Well, fantastic, Koen Driessen. Thank you very much. Comprehensive introduction from Spark Nano.
Yes, thank you. Have a nice day.